Good day, everybody. This is Miggy Ann S, Kaamiño, together with my team, Revelae Golosino and Valerie Vitorillo. Today, we will be showing you how to do direct proof and proof by contrapositive. Enjoy!
First is direct proof. Among all methods of proof, direct proof is the most straightforward. It proves a proposition in the form of if P then Q, or P implies Q, by assuming P is true, and through a sequence of logical deduction shows that Q must be true. Prove that if n is odd, then n squared is also odd. First, assume that n is an odd integer. By definition, n is equals to 2k plus 1 for some integer k. We will now use this to show that n squared is odd. We have shown that if n is odd, then n squared is also odd.
The next proof is proof by contrapositive. Proof by contrapositive is a rule of inference used in proofs where one infers a conditional statement from its contrapositive. In other words, the conclusion if P then Q is inferred by constructing a proof of the claim if not Q then not P instead. To prove a statement using this proof, first you must make a contrapositive statement. Then, assume that not Q is true. Lastly, show that not P must be true. For example, let us prove this statement. For all integers m and n, if the product of m and n is even, then m is even or n is even. Its contrapositive statement is, if m is odd and n is odd, then the product of m and n is odd. Now, we will assume that m is odd, where m is equals to 2x plus 1, for all x is an element of integer, and n is odd, where n is equals to 2y plus 1, for all y is an element of integer. We will now use this to prove that the product of m and n is odd. Therefore, we have shown that the product of m and n is odd. By contrapositive, if the product of m and n is even, then m is even or n is even.
Always remember, never forget to put a fully shaded box at the end of your proof. This symbol is also known as QED or code error demonstratum, which indicates that the mathematical proof is already complete. That's all for today. Thank you for watching!